We're going to begin a tour of one of the most modern automotive manufacturing plants within General Motors, the Oshawa Truck Assembly. Oshawa Truck has earned a number of awards over the years for both productivity and quality. We see the examples of its fine work every day in the vehicles that we sell and service. I must say how impressed I was to see the organization and coordination of activities within the plant, particularly considering the number of elements and parts that are required to actually build a truck. For example, the plant itself. It covers an area of some 3.1 million square feet. Or put it another way, just imagine 83 Canadian football fields side by side. The plant builds only 4-door, half-ton, 2- and 4-wheel drive short box extended cabs. 80% of production is Chevrolet, the remaining 20% is GMC. The plant operates 3 equal shifts per day, employs 3,200 hourly and 275 salaried workers. Daily production is about 1,302 units with a capability of 1,428 vehicles. 85% of its production goes to the U.S. market, and it takes about 20 hours to build one truck from start to finish. To make all of this productivity possible requires a lot of planning and coordination with suppliers. 3 railway lines bring in the sheet metal and frames. 38 transport receiving docks surround the plant. Some 2,000 parts are used per vehicle. 250 transport trucks unload each day. Employing a just-in-time inventory management system, the plant maintains a 4-hour bank of major material. It takes a great frame to provide a strong foundation for a GM truck, and we have a great truck. The frames are delivered to the plant by rail car. 2 types of frame are used, one for 2-wheel drive and one for 4-wheel drive. An overhead crane picks the frame from the rack and places it on a pedestal on the floor. A frame carrier chassis AGV, or automatic guided vehicle, moves in to pick up the frame for the start of the assembly process. The carrier automatically moves out to the staging area. Construction actually starts with the frame upside down to facilitate easier attachment of the various components. The first stop is to have the rear leaf springs attached to the frame. You can see that the hangers of the leaf spring are color-coded, and in this case they're blue. Both sides must match up to ensure that the proper springs are installed. Next we move to the front hub installation. This department also installs coil springs if the truck is a 2-wheel drive. Remember, 4-wheel drive use torsion bars for springing. This is a 2-wheel drive. You can see the coil springs being added. From here we go to exhaust systems, and don't we wish it were this easy to do at replacement time. The rear axle is installed next. They arrive in the plant fully assembled from an outside supplier and in build sequence for installation. Each unit has a bar-coded label attached to it which is scanned to ensure that the proper axle is being installed in the correct truck. Computerized scanning also permits easier tracking of units if a recall were required. Next, we see the front differential being installed in a 4-wheel drive vehicle. And while it may appear that some parts are not being bolted on, the actual bolting into position may be done at the next workstation. 2 types of prop shafts are used in the pickups depending on the engine size. Here we see the aluminum one used with the 5.3-liter V8, and as you can see, it's relatively lightweight. Next we have the 2-piece steel shaft that's used with the 4.3-liter V6s and the 4.8-liter V8s. Of course, the fuel tank is an important addition, and it goes in next. Now, once the major underframe components have been installed, we have to turn the frame right side up in order to add the rest of the drivetrain. The frame goes back onto the same AGV to continue the assembly process. We saw the front and rear brakes being installed earlier. Now we see the brake evacuate, fill, and test being done. First, the air in the brake lines is evacuated. A valve is opened and brake fluid is drawn in. The system is then pressurized up to 119 pounds per square inch, so any leaks will create an audible tone to alert the operator that something has not been properly fastened. The system is pumped up 3 times and then subjected to a final high-pressure test. Once passed, a computer stamps the inspection card. If this process were not completed or approved, the vehicle would not be released for shipping at the end of the line. Engines used in the Oshawa Assembly come from Romulus, Michigan and St. Catharines, Ontario. Here we see one of the special engine carrier AGVs moving in for pickup. The next stop is transmission installation. The operator removes the shipping cover prior to mounting to the engine and tightening down. And here the transfer case for a 4-wheel drive is being installed. Installation of the starter is completed as a one-piece action with equipment specifically designed for that function. The engine wiring harness is next, and as we saw earlier, verification by scanning is done to ensure use of the proper harness for that engine. Crossover pipes are installed and secured, followed by the serpentine belt and the engine fan. The engine is now dressed and it's ready to move on to be married up with the frame. At this point, the prop shaft is installed to the transmission. Next is the installation of the radiator support module. It's received from the supplier complete with headlights, windshield washer bottle, radiator hoses, and fan shroud installed. It's manufactured specifically for the vehicle it is installed in, as determined by a sequencing list sent to the supplier by computer, either Chevrolet or GMC. And finally, we have installation of the rear step bumper. From here, our unit goes to the marriage station where the body is attached. Pre-stamped panels are delivered by rail from one of 2 U.S. plants. They are on specially designed carriers for efficient handling. The plant maintains approximately 4 hours of material. One of the first parts to start construction of the cab is the cross sill. This operation is typical of assembly jobs in the body shop. The operator loads the parts onto the welding platform, where the robot takes over doing the required spot welds and then moves the part to the next assembly area. The advantage of pre-stamped parts is simplified assembly. The body shop is where we see the greatest application of automation and robotics. 435 robots are used in the body shop area. No manual welding is done. The truck floor pan is constructed using 2 pieces of stamped steel. Here we see the front half being loaded onto a carousel along with some mounting brackets. Next is the rear half of the floor pan being loaded for welding to the front portion. You can plainly see the rear sill. The floor pan then goes to have the seat mounting studs attached. This is a great example of the precision of robotics. The inner shell of the truck cab is called the bird cage. At this station, the rear cross member is being attached. It's at the multi-welder where we really can see the robots in action. Each robot has a specific job to do in a specific sequence. By the time the body's assembled, it will have approximately 2,400 precision welds. But just because the welding is finished, the job is not done. Each unit must undergo perceptron vision gauging. This procedure is necessary to ensure the dimensional integrity of the finished product. The cab is checked using laser cameras that are trained on locating pins or holes in the cab. Over time, a gradual shifting occurs in the cab dimensions. This is picked up by the cameras and is corrected to maintain the strict tolerances required in the finished product. Front doors of the truck are attached to the cab using temporary hinges. As you're going to see later, the doors will be removed for assembly while the interior of the cab is being finished. The assembled sheet metal of our truck then goes through a series of dips or baths. The body is submerged in large tanks in a 9-stage process of dips and rinses called alto phosphate. This is designed to both clean and prime the metal prior to painting. The phosphate cleans the metal. This is designed to both clean and prime the metal prior to painting. The phosphate cleans the metal. The alto electrostatically primes the surface. The vehicle stays on the same carrier it left the body shop on. The primed surface is then dried. From here it proceeds to the paint shop, where the paint primer surfacer is applied. White primer is used on vehicles to be painted white. Dark gray is used for all other colors. The main purpose of the primer surfacer is to reduce the amount of UV rays passing through the clear coat finish, where they might cause a chemical reaction between the base coat and the primer, resulting in paint delamination or flaking. 4 robots apply the primer. The surface is then dried before painting. The plant is equipped with 10 paint spray modules. A barcode located on the front of the carrier tells the robot what color is to be applied and where to spray the paint. The robots pick up the proper amount of paint for the job and atomize it for application with water. General Motors uses waterborne paint, which is more environmentally friendly than others, such as lacquer or enamel. It takes just 3 minutes for 4 robots to apply the paint. Once the base coat has been applied, the unit undergoes a 3-minute flash-off at 165 degrees Fahrenheit. This is designed to extract the water from the base coat paint. This is followed by an application of acrylic enamel polyurethane clear coat. 4 robots use Bell sprayers to apply the clear coat. These are special applicators that apply the finish in a mist. From here, the unit goes through an observation area, and then it's on to a 12 to 15-minute bake at 165 degrees Fahrenheit. This dries the paint enough that sanding could be done if minor flaws needed to be repaired. From here, the unit goes to a final bake of 20 minutes at 165 degrees Fahrenheit. If a 2-toned vehicle were being produced, the secondary or the accent color is finished first. It is then hand-taped and papered before the second color is applied. Once the job is released from the paint department, an order is sent to local suppliers, such as Lear Seating, to produce the required seats for that specific vehicle by style and color. Remember, the plant operates on the just-in-time delivery system, requiring outstanding efficiency and communication. And as we have seen here, the body and paint shops are extremely efficient, thanks in no small part to automation. Once the painting and drying process is complete, our truck heads for the trim department for interior finishing. There is anywhere from a 2.5 to a 5-hour lead time from the end of paint to the start of general assembly. In order to complete the cab trim process, it's necessary to transfer the body to a new carrier. This is done at the cab box transfer, where the cab and the box are transferred onto a trim automatic guided vehicle. Front-end sheet metal, including the hood, fenders, and the tailgate, go upstairs to an electrified monorail system and are moved to a separate line where finishing takes place. They will be matched up with the body later in the cycle. The box goes along for a ride on the top of the carrier while the cab is assembled. I mentioned earlier that the doors are only mounted on temporary hinges during body priming and painting. Now they are removed and mounted to an electrified monorail system and sent to the door line for finishing. With the doors removed, there's easier access to the cab for assembly. Now the first piece to go into the cab is the firewall insulation. This is followed by installation of the upper and lower latch strikers for the third and the fourth door. The 4th door. The 4th door is installed. 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 The 4th door is insta The floor sound deadening insulation is installed at a stock pick station, which is where parts are placed into the cab for installation at the next work island. Here we see the operator placing the brake booster, ductwork for the heating and air conditioning, and the weather stripping for the rear door into the cab. The cab has now arrived at the next workstation and is having these parts installed. Here we see the brake booster and the weather stripping being added. The parking brake is installed prior to additional interior finishing. Floor carpeting is next. The carpets are received from the supplier in sequence to match the build schedule by color as the job is released from the paint shop. And here's an interesting point. The necessary holes in the carpets are cut using a water jet that operates at 40,000 pounds of pressure per square inch. The water is recyclable and environmentally friendly. The headliner is installed next. The heating, ventilating, and air conditioning follow this. Now, the instrument panel is installed as a single piece. This is just one of the assembly areas where we see automation working hand in hand with manual labor, thus improving the process. Once installed, the dash cover and passenger assist handle finishes the job. Trim and seat belts for the outboard rear seat passengers are installed along with sill trim for the rear window. The jack and the jack toolkit are then added. And finally, trim molding for the A-pillar and for the dash panel add the finishing touch. From here we go to a very interesting part of assembly, installation of the windshield and rear windows. It's where we meet the robots again. The operator picks a windshield depending upon model with or without a compass in the rear view mirror, and the robot takes over. First step is to clean the edge of the glass and then to prime it for the sealer. The windshield is then handed off to another robot that applies the urethane sealer and installs it into the cab. The sealer takes 48 hours to cure. As the glass is installed, it pushes out any air around the edge of the windshield and the urethane, creating a suction that holds the windshield in place. Laser cameras guide the robots into the correct position for installation. While difficult to see, they are the rectangular units painted in red. Two robots do the rear quarter glass installation. One applies the sealer to the glass and then hands it off to its partner. Both windows are installed at the same time by the robots in order to equalize the pressure being exerted against the side of the cab. The table supporting the cab is capable of moving up and down and turning 90 degrees. Our cab is now ready for seat installation. Seats are ordered from the supplier at the time the job is released from the paint shop. They are received at the plant on special carriers in the correct build sequence to match each truck color. Again, we see an outstanding application of automation assisting the assembler with the rear seat installation. A little finishing work is needed before we add the front seats. Here's the driver's side airbag being installed. Next to follow is the center console and the front seats. They arrive on the overhead monorail carrier. Now the operator removes the seat from the carrier and using the assist arm installs it in the cab. Because this seat is power operated, he attaches the electrical wires, and at the same time he's going to add grease to the hinges in preparation for the later remarrying of the doors with the cab. Next stop is the addition of the cruise control module and the front cowl cover. And this is followed by the center high-mounted stoplight. Now the doors can be attached. Having been outfitted by trim and hardware on a separate line, they are once again united with the cab. Doors are finished with weather stripping. and the sill plate is added to finish off the cab. From here, it's off to the marriage station to be matched up with box and chassis. When a truck comes into the marriage station, the cab and box are lifted off of the automatic guided vehicle. The AGV goes back to the trim and hardware line to pick up another cab and box coming down from the paint department. The cab and box are then brought to the same level position for mounting to the frame. You can see the arms of the body mount fixtures positioning themselves in preparation for the mounting to the frame. There are the orange units to the left of the vehicle. The chassis is indexed onto the chassis AGV. The body mount fixtures go into place and the cab is lowered onto the chassis. The body mount bolts are driven in automatically from below. The fixtures retract and the AGV leaves the marriage station. Here we see a good example of ergonomics being applied during the assembly process. The operator stands in a shallow side pit, working at a comfortable height with no unnecessary bending of the neck. He's using a hydraulic articulating arm to position the gun or fixture as he installs the body mounts. This operator is attaching the master cylinder to the firewall, having just fastened a clip onto the brake booster. Put on the master cylinder, start the nuts, and then torque them down. This is radiator evacuation and fill, and the first step is to evacuate the air out of the radiator. Then fill the reservoir and the system, and then level the fluid in the reservoir. Step-side models have a wheelhouse liner above the rear wheel and axle. Here the liner is being installed. Again, note that the installer is Step-side models have a wheelhouse liner above the rear wheel and axle. Here the liner is being installed. Again, note that the installer is working in a shallow pit for optimum ergonomic benefit. Now, before the tail lights can be installed, the mounting bracket for the tailgate must be attached. In addition to the tail lights, we also connect the trailer wiring harness at this station. You may recall that all body parts are painted at one time, then separated and sent to different areas of the plant on an electrified monorail system for finishing. Now everything comes together as we approach final assembly. The hood is installed. The tailgate is added. The front bumper is attached. Body side moldings are applied. And the grille and the closeout panel complete the body. Tire mounting and inflation is a fascinating operation. Tires are automatically mounted to the selected rims and then inflated. Inflation is actually done by adding air around the rim instead of through a stem and valve for improved speed and efficiency. In our sequence, you see 4 matching rims for the truck plus a standard steel rim that is the spare tire. Remember, all full-size pickups come with a full-size spare tire. The plant unloads 13 transport truckloads of tires per day. With a daily production rate of 1,300 trucks and 5 tires per truck, daily usage totals 6,500 tires per day. Now we can understand the need for automation. Wheels and tires arrive at the assembly line from the tire room. Here we see a spare tire being installed. For the regular wheels, the tire installer starts 3 nuts when mounting the wheels. The next operator adds the remaining 3 and torques them down according to specifications using a multi-gun. Torque is monitored to ensure proper installation. A green light indicates that everything is okay, red is under-torqued, and yellow is over-torqued. This is truck unload. The truck is removed from the chassis AGV. This is where the rubber meets the road for the very first time. But trucks can't run without fuel. At fuel fill, approximately 19 liters are added to the tank. And as you can see, the filling is done automatically. As we approach the end of the assembly process, quality checks begin. This operator scans the barcode that is entered into the computer. She checks the gas cap installation and ensures that the wheel nuts are the correct match for the wheel rim. 9 similar stations are found as we come to final assembly. Any defects or repairs are entered into the computer through a touch screen. This information allows statistical analysis of the manufacturing process on a daily, shift, or weekly basis. At startup and test, 193 line items are checked. Everything from air conditioning to turn signals to brakes and airbag systems are covered. A computer is plugged into the vehicle computer circuits and all results are recorded for analysis. The inspector follows the sequence of checks as directed by the computer. Apply the brakes, apply the turn signals, honk the horn, etc. After initial startup, the transmission fluid is topped up. The vehicle is then driven off the end of the line, but that's not the end of our evaluation. Headlight aim is checked while robots check the wheel alignment and toe in. We've now arrived at the roll test. The driver passes the vehicle identification card under the scanner recording all vehicle options. A computer monitor then comes across to the operator. Floor-mounted rollers take the vehicle up to 60 miles per hour or 100 kilometers per hour, checking functions such as the upshift and the downshift of the automatic transmission, the anti-lock brakes, and the four-wheel drive system. It also looks for drag on the wheels. All vehicles must go through this test. The steel bars you see are required to ensure that the truck does not leave the rollers while being tested. After this, our truck heads for the care line where inspectors check for fit and finish. Once past this final examination, it's out the door and on its way to a GM dealership for delivery to a lucky customer. Quality product is not achieved by accident. Constant checking and verification of materials as well as process is critical. At General Motors, product evaluation and testing is a daily activity. A number of examiners spend their days making sure that only the best product leaves the plant. Today we're following Gene Deneen as he performs a complete vehicle audit and road test. Once the vehicle has been selected, it's brought into the inspection area. All pertinent information about the truck, such as the make, model, trim, axle, and vehicle identification number, is recorded into a handheld computer. As he conducts the inspection, any discrepancies will be entered into this unit. All records will be transferred to the main plant computer at the conclusion of the evaluation. Inspection begins with the engine compartment, where all fluid levels, hoses, connections, and fittings are checked. At the same time, inspectors look for any stress on wires or hoses, plus they look for fluid leaks. From here, we move to the cab. The inspector checks all operating parts for correct function. Items such as lights, the turn signals, warning chimes, seatbelt attachments, the horn, the radio, sun visors, heating, ventilating, and air conditioning controls, mirrors, as well as the shift lever. Seat movement, both front and rear, the recline function, the grab handles, window openings, door locks, and latches are all examined. Outside, body fit and side moldings are inspected. A special gauge is used to determine consistency in body panel gaps. At the same time, inspectors examine the paint and metal finish for flaws. Variances are recorded in the handheld computer. At the rear, tail light installation and proper attachment of the tailgate is examined. Even the key lock for the spare tire is checked. Once a thorough examination of the interior of the cab and the vehicle exterior is complete, the truck is placed on a hoist for an under-vehicle evaluation. Tires, wheel nuts, suspension, exhaust attachments, and more are all reviewed for proper assembly. The inspector also notes any fluid leaks or spills. When the detailed shop inspection is complete, the truck is taken for an on-road evaluation. The first stop is the squeak and rattle track, which comprises of a series of bumps designed to expose any defects. The truck is taken over the track in both forward and reverse gears. Should problems be detected, the vehicle will be turned over to the squeak and rattle department to determine both the cause and the fix. Steering is initially checked through a series of figure-8 moves. On the road, the inspector checks the tow-haul mode for correct operation, and at the same time, the cruise control is put through its paces. The truck is driven approximately 5 miles as a warm-up for both the engine and transmission. The radio is checked for static on both the AM and FM bands, and the windshield washer system is tested. While at highway speeds, the inspector also listens for any unusual wind rush or noise. Once the warm-up is complete, the powertrain evaluation starts. First up is a quarter throttle acceleration to check upshifts of the transmission. A slight grade is used to check proper function of the parking brake. Then it's on to the half throttle. And finally, a full throttle performance test. The transmission is allowed to coast down to allow the inspector to check for proper shifting. The park pole function is very important. This test is conducted in both reverse and forward gears. With the truck moving at about 6 miles per hour, the transmission is shifted into park. The park pole should engage and stop the vehicle. Steering wheel movement is checked for the stop-to-stop maneuver. Brake testing is accomplished through a panic stop from a speed of 40 kilometers per hour. Here, the driver is checking for any pulling action. The truck is then taken up to about 30 miles per hour or 42 kilometers per hour to check for upshifts and downshifts from third to first and back again. The complete round-trip test covers 19 to 21 miles. The course was designed to allow the truck to be driven in 4 different directions. This is necessary to determine the effect of wind rush or noise on passenger comfort. The course also requires an equal number of left and right-hand turns, simulating real-world usage. Once back at the plant, the truck will be subjected to an 8-minute water test in order to evaluate seals. Again, any discrepancies will be recorded in the handheld computers. Only after all of these tests and any required repairs are completed will the truck be released for delivery. So the next time you see a truck which has gone through an individual inspection and road test, smile, knowing that this vehicle meets the standards set by Colonel Sam McLaughlin so many years ago. 1 grade only, and that the best.